So let us start with the first question. The quadratics k squared plus 7x plus k and k squared plus kx plus 7 have exactly one common root. If k is not equal to 7, what is the value of k? Sorry, can you reshare the screen?
Oh, okay. Hold on. Right there.
Okay, going back to this. So what we can do over here is, okay, so what is the first thing that we need to do?
Subtraction.
Okay, so seeing that both are monic polynomials, basically the leading coefficient is 1. What can we say about the factorization of both of these?
So the first one, x squared plus 7x plus k minus x squared minus kx plus 7.
Wait, can you say that again? Couldn't understand you.
I say that we have if we get if x squared plus 7x plus k minus x squared minus kx minus 7, we get x time 7 minus k minus 7 minus k.
Not quite. I'm actually pertaining to the factorization based on the roots. Okay, so what we will be doing over here is, okay, so your observation is your observation would be okay, but the actual solution to this would be to use the following method. Give us a minute. Okay, that's actually correct. Okay, that's actually correct. One way would be to let the common root be r. Okay. Okay, can you give me a minute because I am unable to annotate.
Oh, hold on. Uh, actually, hold on. I'll stop share first. Sorry, guys.
Okay. So going back to this question, the quadratics x squared plus 7x plus k and x squared plus kx plus 7 have exactly one common root. If k is not equal to 7, what is the value of k? So as one of you guys said, let the common root be r, which means that our equation would be r squared plus 7r plus k equals r squared plus kx plus 7. And then the next thing we will do is subtract r squared from both sides, which gives us 7r plus k equals to kx plus 7. Given that given this structure, okay, okay, what's the next step that we will do? From this, what's the next step we will do? Okay, it would be to transpose everything. You got that correct. So after we transpose everything, what we will get is KR minus 7R minus K plus 7 equals 0. The final step will be to factorize it using Simon's favorite factoring trick. I'm sure some of you guys know that, right? And then from here, we will have R minus 1 times K minus 7 equals 0. We can get R minus 1 equals 0 and K minus 7 equals 0. However, we can't have K is equal to 7, so we're going to cross that out. And so R must be equal to 1. Next, let us plug that into our original equation. And in this case, we will get 1 plus 7 plus K equals 0. So K equals to negative 8, which is letter A. Also, there is a longer solution to this. So let the common root be x minus r and x minus s. Let the common root be r. And then for the second equation, k squared plus xk plus 7 equals to x minus r times x minus t. So if we're going to expand both of these equations, we're going to get x squared minus r plus s times x plus rs. For the second equation, we will have x squared minus r plus t, x plus rt. So one way we will eliminate the variable r would be to consider that that rs equals to k, because we're actually comparing the coefficients on the constant term of this polynomial and the constant term of that polynomial, which is why rs equals to k. Next, for the other polynomial, kx squared plus kx plus 7, okay? We're going to have rt equals to 7. So if we're going to divide both of these polynomials, what we will have is s over t equals to k over 7. Next, we will get r plus s equals to negative 7. Why is that so? This is because negative r plus s is equal to 7. So if we have r plus s, that will give negative 7. Wait a minute. Similarly, for r plus t, we get negative k. So if we subtract both of these equations, we get s minus t equals to 7 plus k. And also s equals to t plus 7 plus k, which gives t over 7 plus k over t equals to k over 7, which in turn gives 7t plus 49 plus Again, for some of you that get confused, this is the longer solution, even though I would not recommend you do this in a contest. So in this case, what we will be doing is expand the equation like so. And using the similar logic, we can transpose everything to one side and then factor this out. It gives k times 7 times t times minus 7 equals to 0. Mhm. Hmm. Okay, correction. Mhm. While I'm trying to find a way to figure out how to fix this annotation, I'll have to ask something. How is this problem for you? Did you find it confusing or were you able to follow? Okay, I managed to fix the issue right now. So using this equation, what we will be getting is 7k plus 49 plus 7k. Okay, sorry. For this, what we will be getting is 7t plus 49 plus 7k equals to kt. Mhm. If we factor this, if we factor this using Simon's favorite factoring trick, or which is known by the acronym SFFT, we will get kt minus 7k minus 7t equals to 49, which in turn will give k minus, okay. Again, as I said, this will give kt minus 7k minus 7t equals to 49. If we, mhm. Actually, this is supposed to be negative 49. It's a correction. Actually, it's positive 49, so ignore that one. Mhm. Okay, actually, okay. Mhm. And if we add, and using this equation, if we add 49 to both sides, what we'll be getting is k minus 7 times t minus 7 equals to 0. Since we cannot have k equals 7, the only possible solution is t is equals to 7, from which um from which inserting this into our earlier equation, rt equals to 7, we will get r equals to 1. So what we get is, what we will be getting is, so what we will be getting for these equations is rt is equal to 8. Mhm. So given that r equals to 1, then t equals 7, we will have negative r plus t equals negative 8 equals to k. From this case, we will get k equals to negative 8, which shows that our answer is A. Is everyone able to follow, or do you want to ask something? Okay, able to follow. That's good. Is there anyone else who's confused on this problem? None. That's good.